today we're going to take a look at section 10.4, and it's on solving radical equations. Okay, so eventually we're going to try to solve an equation. We're going to get x by itself on one side of the equation. That's kind of the goal. But before we get to that, a little quick refresher on how to solve a quadratic equation. Okay, our goal here is to get x by itself, so I'm going to divide by 5. That gives me 25. And then here's the whole key for today that I'm going to point out. How do I get rid of a square? Well, when we did this before, what we did is we square rooted both sides. And the square root canceled out the square. And we got plus or minus 5 as an answer. But what I really want to emphasize is this right here. What canceled out a square was the square root. They kind of nullify each other. Okay? Let's take that thought as we go on to these next ones here. Now, when we solve an equation here, it's going to have a radical in it. And we're going to get an answer, and it's going to be really important today to check your answers. Sometimes it's going to look like we get one answer, sometimes it's going to look like we get two answers. But sometimes they're not all going to work. Sometimes only one might work, sometimes none of them might work. So even though it's going to be an extra about 30 seconds for you to check your answer, you need to do it. Okay? All right, so here's the example one that we're going to see today. And before we get started here, just real quick, we're going to take a look at a lot of examples today. I'm going to try to cover all the types of problems that you're going to see so that hopefully there aren't any issues on your homework assignment. Okay, so bear with me. It might get a little long, but try to stay tuned in if you can. Okay, here's an example of an equation that has a radical in it. Okay, when we solve equations that have radicals, the very first thing we have to do is we have to get that radical term all by itself. And that's this one right here. Okay, this does not have a radical in it, so we need to get rid of the 7 by adding 7. And I get 9 over here. Okay? Now, once I get this radical term by itself, now we have to get rid of the radical itself. And kind of like what we talked about a minute ago, what cancels out a square root? Well, we said on that first page, the square of something cancels out the square root. So if I square both sides, if I group everything on the left and everything on the right, and I raise it to the second power, the square cancels out the square root, and there we do have just little old x all by itself. And the 9 squared is 81. Okay, so but we need to check it. Does 81 work? Well, let's plug it back in right up here. If I plug in 81, the square root of 81 is 9, and 9 minus 7 is 2, so it works. That's a nice short, that was a really nice short, easy little check. Okay, but again, the whole key for today is the way I get rid of a radical is we square both sides. And we're going to see that a lot. Here's another one. Okay? This time there's a little bit more stuff under the radical, but I still have something that's not under the radical. Well, before we go any further, we have to get that radical term by itself. So let's add 2. Is equal to 8. Okay? And now, again, once that radical term is by itself, I'm going to square both sides to get rid of the radical. The square and the square root cancel out, and 8 squared is 64. Okay, and now we just have a nice little algebra problem. Let's solve it. Okay, let's subtract 1 and divide by 3. And I'm doing that kind of fast, but if you get there, you'll get x equals 21. Okay, now to do a check, again, you can kind of do what I did in my head, or you can use your calculator as well. You can certainly plug in 21 right here and just do it all in your calculator and see if it equals 6. Well, I'm going to do it in my head here. 21 times 3 was 63. 63 plus 1 is 64. The square root of 64 is 8. And 8 minus 2 is 6. So again, it works. Okay? One last one here. This one has a whole bunch of stuff along with the radical. But like I said before, the very first thing we have to do is get the radical term by itself. There it is. We need to get rid of the 12. We're going to get rid of the 12 by subtracting 12. And if I do that, I get 16. Okay? So I got the radical term by itself, but now I have this 4 out in front. I don't want the 4 in front. What's the 4 doing to the radical? It's timesing the radical. So to get rid of times by 4, we divide by 4. Okay, they cancel out. 16 divided by 4 is 4. Now we have that radical all by itself, and now I can get rid of it by squaring. But you can't do any squaring ahead of time until you get just the radical alone. The square and the square root cancel out, and I get 16. Okay? And to solve for x, if we add 7, oops. If I add 7 here, I get x equals 23. Okay? Let's see if it works. Does it work? Again, you can use your calculator, or I'm just going to plug it in. 23 minus 7 is 16. The square root of 16 is 4. 4 times 4 is 16. And 16 plus 12 does equal 28. And it checks. And again, I did that check really, really fast. Certainly go slower. Use your calculator if you need to. Okay? But so far everything's been good. Okay? But again, we isolate the radical term, square both sides, and solve it. Okay? Now we're going to skip that. It's going to be the same thing. Okay? Some special ones here. I have a couple different kinds of special ones. Here's the first kind. If I look closely at this one, it has 2 x's in it. Okay? There's only one radical, but now there's an x term over here. Okay, well, we're going to go through the same process as we did earlier. Let's get the radical term by itself. Well, it is already by itself, so we're in business. Okay? And once it's by itself, I'm going to square both sides. Okay, just like I did before. The square and the square root cancel out. And over here now I get x squared. And this is where the game changes a tiny bit. When we have x squareds, what we're going to have to do is we're going to have to move everything over to the x squared side so that the equation is equal to 0. Okay, so I'm going to move these guys this way. I'm going to subtract 4x, and I'm going to add 3. Okay, now I can combine those. Okay, not that we're into a little bit of a problem, but those cannot be combined. So how do we solve one of these that has an x squared in it like that? Okay, well, this is going to take us back a little ways. The way we're going to do that is we're going to solve it by factoring. Okay? And when I factor, I look at the first term first. X squared breaks apart into an x and an x. And then if you remember, we look at the last term. The factors of 3 are 1 and 3. And we need to do it, put them in there and put the signs on there in such a way so that when I FOIL here and here, I end up getting the middle term of negative 4. Okay? Well, if I put in a 1 and a 3, I get a 3x and a 1x. How do I get negative 4x out of that? I think I can get a negative 4 if both of these are negative. Okay? Both of them are negative, give me negative 4x. Okay? And once I get it factored, then I solve it. And if you remember to solve it, what I do is I set each of these equal to 0. There's a little bit of a shortcut, but most of you guys were setting them equal to 0 and then solve it. If I add 1, x equals 1. And if I add 3, x equals positive 3. So it looks like it has 2 answers. Let's check and see if they work. Let's plug in a 1. 4 times 1 is 4. 4 minus 3 is 1. The square root of 1 is 1. Does 1 equal 1? Sure does. It works. How about a 3? 4 times 3 is 12. 12 minus 3 is 9. The square root of 9 is 3 on that side. And if I plug in a 3 over here, does 3 equal 3? They both work. Yep. So we're in business. Okay? But this is going to be the tricky part right here, is doing the factoring. Okay? That's going to go back a while back. Okay? Here's another one of these. Let's try this. There's one radical in it. Okay? It's already by itself. So we can get rid of it by squaring both sides. Okay? The square root and the radical go away. And I have an x squared again. And anytime we get x squared, we have to move everything over to one side. So we're going to move these things over. So we get a 0. I'm going to add x and subtract 20. And once again, we're going to have to factor. Okay? My factors of x squared are x and x. Oops. And if you use your factor sheet, the factors of 20 are 1 and 20, 2 and 10, or 5 and 4. And we need to put them in there in such a way so that we get a positive 1x. Okay? And I think if I did a positive 5 and a negative 4, negative 4x and positive 5x is going to give me 1x. Okay, so that's how it factors. And then if I solve it, x plus 5 equals 0, x minus 4 equals 0. X could equal negative 5, and it looks like x could equal positive 4. So again, it tentatively looks like it has two answers. Okay, I'm going to try the 4 first. If I plug in a 4, let's do this. 4 right here. 20 minus 4 is 16. The square root of 16 is 4. Does 4 equal 4? Yep, it works. How about negative 5? If I plug in negative 5 right here, negative 20 minus negative 5, if I do a change, that's 25. The square root of 25 is 5. Does 5 equal negative 5? It does not. That one does not work. Okay, that's what's called an extraneous solution. So it looked like there were two nice answers. But that one did not work. There's only one answer to this. Okay, but we didn't do anything different. Okay, we still solve it the exact same way, but again, it's that check that we have to be careful of. Okay, this is also another special one that I want to throw out there. It doesn't look any different. There's one radical. Okay, the radical's on the right. The radical's by itself. So we're going to square both sides again. Okay, on the right-hand side, the square and the square root cancel out, so it's just 13x minus 10. But what about on the left? This isn't just 2x squared. You also have to square the 2 to get 4x squared. Square the 2 and the x. Okay, now this one has an x squared again. This time it's on the left. We have to move everything over to the x squared side, so I'm going to move these two things over. Minus 13x plus 10 equals 0. And whenever we have an x squared, we're going to have to factor. Okay, now my factors of 4 are 1 and 4 or 2 and 2. And there are my factors of 10, and we need to put them in there so we get 13, negative 13. Okay, I'm going to try a 4x and a 1x. Okay, and for this one over here, I'm going to try a 5 and a 2. Oops, I'm going to switch them around. Okay, the factoring can maybe take a little bit of a while, but if I do a 2 and a 5, let's check this. There's 8x and 5x. Can I get negative 13x out of the deal? And I can if they're both negative. Negative 8 minus 5 is negative 13. So I get negative 8 right there, negative 5 right there. Okay, and if I solve it, okay, 4x minus 5 equals 0, and x minus 2 equals 0. Okay, and if I add 5 and divide by 4, it looks like x equals 5/4. And if I add 2, it looks like x equals 2. Again, it looks like two answers. One of them's a fraction. Is that possible? Okay, let's try it. If I take 5/4 and I plug it in right here for x, and this is something you can certainly use your calculator on. 2 times 5/4, okay, it's going to tell you 2.5. Okay, this side is 2.5. Okay, if you take 5/4 and plug it in right here, just remember to put it in parentheses. 3 times 5/4 minus 10, I think you get 6.25, and if you take the square root, you'll also get 2.5. And they're equal, so 5/4 works. Okay, what about the 2? If I plug in the 2, 2 times 2 is 4. What about this side? 13 times 2 is 26. Minus 10 is 16. The square root of 16 is also 4, and it works. So it's okay to have a fraction as well. Okay, but again, really important to do the check. Okay? All right, here's another one. Okay, I think you're going to see this is the last of this kind of special ones. Okay, there's only one radical, but now there's more than one thing over here. Okay, well, the radical is by itself, so we're going to square both sides. Okay, and and I get 2 minus x because that cancels out. Now what about the right-hand side? How do you square x plus 4 squared? Well, to square something means we write it twice and then we're going to FOIL. And I'm going to FOIL this really fast. I'm going to get x squared. I'm going to get plus 4x plus another 4x is 8x plus 16. And if you look again, there's an x squared, so everything has to go over to the x squared side. So I'm going to add x and I'm going to subtract 2. When I add x, I get 9x. Subtract 2, I get 14. Okay, and when I have an x squared, I have to factor again. This time it's x and x. The factors of 14 are 1 and 14, or 2 and 7 on your factor sheet. And we need to find the pair that give me 9. Well, I think 7 and 2 can give me 9. I did plus 7 and plus 2. And if I solve it, x plus 2 equals 0. If I subtract 7, I get negative 7. If I subtract 2, I get negative 2. So it looks like I have 2 answers. Let's check them. Okay, if I do negative 7, if I plug in negative 7 right here, 2 minus negative 7 turns into 9. And the square root of 9 is I get a 3 over here. If I put in negative 7 right there, negative 7 plus 4 is negative 3. Does 3 equal negative 3? Nope, it doesn't work. How about negative 2? 2 minus negative 2 is 4. The square root of 4 is 2. If I put a negative 2 in here, negative 2 plus 4 is positive 2. Those are equal. So there's only one answer that works in this case. It's negative 2. Okay? Okay, but again, the whole idea here is that we're getting rid of the radical by squaring both sides. Okay? All right, here's the last 2. More special ones, and these are actually a little bit easier. What's special about this is instead of there being just one radical, there's 2. Okay, well, don't get nervous, don't get scared, it's okay. Let's stick with the theme. Let's get one radical by itself. Well, it turns out both radicals are by themselves. That's a good thing. Once it's by itself, the way we get rid of it is we square both sides. Okay? And I know that when I square both sides, the radical part goes away. That cancels out. And poof, the radicals are gone. Both of them are gone. There aren't any x squareds. This is just some x's, so let's get them on the same side. I'm going to move this one over here by subtracting it to get 1x minus 1. And I'm going to add 1, so it looks like x equals 5. If I check my answer, 5 plus 4 is 9. The square root of 9 is 3. If I plug a 5 in here, 10. 2 times 5 is 10, minus 1 is 9. The square root of 9 is 3. 3 equals 3. It works. Okay? All right, very last one for the day. Same thing. There's 2 radicals, but they're both by themselves. So to get rid of them, I can square them. Okay? The radical part goes away. They cancel out. They cancel out. And if I get my x's on the same side, I'm going to move them that way by subtracting 2x. I get 1x plus 5 equals 7. And subtract 5, it looks like x equals 2. Let's check my answer. If I plug in a 2, 3 times 2 is 6. 6 plus 5 is 11. Now it's the square root of 11. It's not a nice number. Let's just leave it as the square root of 11. What if I plug in a 2 right here? 2 times 2 is 4. 4 plus 7 is 11. And I get the square root of 11. They're equal. And it works again. Okay? So once again, the whole key with all these radical problems is get the radical by itself, then square both sides, and solve. And once you get a solution, make sure you check your answers. And I think we can all agree that there's a fair amount of work to show on these as well. Make sure you show your work. All right, thanks for tuning in.